The functions printf and scanf are like a mail merge tool. Their first argument is a format string, a piece of text that contains ordinary characters which are printed or ignored, and conversion specifications that act as blanks to be filled. The prototype is int printf takes a const char pointer format and a variable argument list, and int scanf takes a const char pointer format and a variable argument list. In printf, the blanks are filled by the values you pass after the format string, while in scanf, the blanks are read from the input and stored into the variables you provide. Declare an integer age equal to 23. Call printf with the format string you are %d years old newline and the argument age, which prints you are 23 years old. Declare an integer x call scanf with the format string enter a number $d and the address of x. The user types a number and x receives that value. Note the ampersand before x in scanf. The function needs the address where it can store the read value. The format string can contain any characters. They are printed or expected exactly as they appear. Anything after % starts a conversion specification. The characters after % up to the specifier such as D, F, or S tell the function how to interpret the corresponding argument. Both functions return an integer. Printf returns the number of characters printed, while scanf returns the count of successfully matched and assigned input items, which is useful for error checking. %d or %i signed decimal integer, for example -12 and 34. %u unsigned decimal integer, no sign, wraps around at 2 to the 32-1 on 32-bit. %o unsigned octal base 8 representation, useful when working with file permissions. %x/%x unsigned hexadecimal base 16. %x uses lowercase a to f, %x uppercase. %ld, %li, %llu, etc. Same as above but for long and long types. Add length modifier L or LL. %f prints a decimal notation like 123.456. The default precision is 6 digits after the decimal point. %e/%e scientific notation. For example, 1.23e plus 02, useful for very large or small numbers. %g/%g chooses the shorter of %f or %e representation. %lf for long double values use L-length modifier. %c a single character. In scanf, whitespace is not skipped unless you put a space before %c. %s a null terminated character array, see string. The array must be large enough for the input plus the terminating \0. %open bracket ... close bracket scanset specifier reads a sequence of characters that match or do not match the set inside the brackets. %p prints a pointer value in an implementation-defined format, usually hexadecimal prefixed with 0x. %% prints a literal % sign. Each specifier may be preceded by optional flags, width, precision, and length modifiers covered in the next topic. Choosing the right specifier prevents mismatches that lead to undefined behavior. Real-world analogy. Think of a specifier as a label on a form. %d is the label age integer, %f is price decimal, and %s is name text. The program fills those labeled blanks with the appropriate type of data. Formatting flags are like the settings on a printer that decide how wide a column should be, whether the text is left or right aligned, and what kind of padding fills the empty space. Field width is a decimal number placed after %. For example, %8d, it tells print to reserve at least that many character positions. If the printed value needs fewer characters, the remainder is filled according to flag rules, default spaces on the left. Example, print vertical bar %5d vertical bar %5d vertical bar backslash n, 12, 12345 close parenthesis semicolon. Output vertical bar space 12 vertical bar 12345 vertical bar. The first number is padded with 3 spaces to reach width 5. The second already occupies 5 characters. Precision for floating point numbers is a dot followed by a number, for example %.2f, which sets the number of digits after the decimal point. For strings, it limits how many characters are printed. For example, %.3s prints only the first 3 characters. Example, print %0.2f backslash n, 3.14159 close parenthesis semicolon prints 3.14. Then print %.4s backslash and comma double quote a b c d e f double quote close parenthesis semicolon prints a b c d. Flag characters are placed before width or precision. Hyphen means left justify within the field, default is right justify. Plus means always show a sign, plus or minus for sign numbers. Space means if the number is positive, leave a leading space instead of a sign. 0 means pad the field with leading zeros instead of spaces, ignored when hyphen is present. Hash means alternate form. For %O it adds a leading 0, for %X or %X it adds 0x or 0x. For %F, %E, %G it forces a decimal point even if there is no fractional part. Combined example printing a table of money values with a leading sign, 2 decimal places, and a total width of 10 padded with zeros. Print %+010.2f backslash and comma minus 45.6 close parenthesis semicolon prints minus 00045.60. Explanation. Plus forces a sign, 0 pads with zeros, 10 is total width, dot 2 is 2 digits after the point. Analogy, think of a bookshelf. The field width is the width of each shelf, precision is the number of books you allow on the shelf, and flags decide whether the books start at the left edge, right edge, or have decorative spacers zeros between them. Using these controls you can align columns, create neat tables, and satisfy the formatting requirements of many programming contests. Explanation. Reading and writing the 4 basic data kinds is the core of most competitive programming problems. Integers use %d or %i for int, %ld for long, %lld for long. Example, int n, scanf %d ampersand n, print view entered %d. Floating point %f for float or double, both are promoted to double in variable arguments. %lf is the same as %f for scanf. Example, double area, scanf %lf ampersand area, print area equals %.3f. Characters %c reads a single character. Beware of newline characters left in the input buffer. Adding a space before %c in scanf skips any white space. Example, char ch, scanf space %c ampersand ch, print first letter colon %c. Strings %s reads a word, a sequence of non-white space characters into a character array. The array must be large enough. Example, char name bracket 30 bracket, scanf %29s name, print hello comma %s exclamation mark. If you need to read a line that may contain spaces, use fgets instead of scanf. Example, char line bracket 100 bracket, fgets line comma sizeof line comma stdin. Mixed IO, you can freely mix types in a single statement. Example, int a double b, char c, scanf %d space %lf space %c ampersand a comma ampersand b comma ampersand c, print int equals %d space double equals %.2f space char equals %c. The spaces in the format string tell scanf to skip any amount of white space, including newlines between the inputs. Analogy, imagine a vending machine. The type of item you request, coin, snack, drink, is like the conversion specifier. The machine expects the right kind of token. If you give a bottle where it expects a coin, it will malfunction, just like feeding a wrong type to scanf or printf leads to trouble. In contests, you often need to read several numbers from one line or write several results on the same line. Both printf and scanf let you place many conversion specifications in a single format string. Reading multiple values, separate specifiers with spaces, or any other literal characters. Scanf treats any white space in the format as a directive to skip any amount of white space in the input. Int x, y, z semicolon scanf %d space %d space %d ampersand x, ampersand y, ampersand z semicolon comment user can type 10 20 30 or 10 backslash n 20 backslash n 30. If the input uses commas, put them literally. Scanf %d, %d ampersand x, ampersand y, ampersand z semicolon comment expects 10 20 30. Writing multiple values, just list them after the format string. Printf %d space %d space %d backslash n x, y, z semicolon comment prints a space-separated line ends with newline. Newline considerations, printf does not automatically add a newline. You must include \n where you want the line to end. Forgetting it can cause the program's output to be concatenated with the next prompt, which many judges treat as wrong answer. Printf result %d backslash n result semicolon comment correct. Printf quote result colon percent d quote comma result semicolon comment missing newline may cause wa. Trailing whitespace, most judges ignore extra spaces at the end of a line, but it is good practice to avoid them. Use precise width specifications or print spaces only where needed. Analogy: think of a train with several carriages. The format string is the train schedule. It tells the engine, the I/O function, how many carriages, values to pick up and where to place them. A missing \n is like forgetting to signal the end of a station. The next train will keep going without stopping. By carefully designing the format string, you can read an entire matrix, a list of coordinates, or produce neatly aligned output in a single call, which is both faster and less error-prone. Buffer overflow, when reading a string with %scanf, does not know the size of the destination array. If the user types more characters than the array can hold, memory beyond the array is overwritten, leading to crashes or security holes. Char buff 10 semicolon scanf %s comma buff. Dangerous, can write past 10 bytes. Solution: limit the field width to 1 less than the array size, leaving room for the terminating \0. Scanf %9s comma buff, safe for buff 10. Alternatively, use fgets, which takes the maximum size as an argument. Mismatch specifiers: the type of the argument must match the conversion specifier. Passing an int for %f or a double for %d invokes undefined behavior. The program may produce garbage or crash. Double d equals 3.14 semicolon print %d \n comma d. Wrong %d expects int not double. The compiler often warns about this when you enable warnings -wal -wextra. Undefined behavior from wrong pointer. In scanf, you must pass the address of the variable &var. Forgetting ampersand passes the value as if it were a pointer, causing the function to write to an arbitrary memory location. Int n semicolon scanf %d comma n wrong should be &n. Similarly, for arrays, you normally pass the array name itself, which decays to a pointer, not ampersand array. Additional subtle errors. Dash using %lf in print is wrong. The correct specifier for double is %f. The L-length modifier is only meaningful for scanf. Dash mixing \n inside a scanf format string can cause it to wait for a non-existent newline, leading to apparent hangs. Best practices. Dash always compile with warnings and treat them as errors. Dash use the exact specifier for the variable type. Dash limit string input with a width field. Dash prefer fgets plus scanf for line-oriented input when safety matters. Analogy: imagine a mail slot that only fits letters of a certain size. Sending a postcard large through it, buffer overflow, will jam the system. Putting a thick envelope in a slot meant for a thin one. Type mismatch will crush its contents. Forgetting to put the address on the envelope ampersand means the mail carrier has nowhere to deliver the letter. Many algorithmic problems require presenting results as tables, matrices, or neatly aligned lists, for example, printing a multiplication table or the adjacency matrix of a graph. The step-by-step approach. Determine column width. Choose a width that can hold the largest number. For an n by n matrix of integers, the maximum value is often n or n squared. Use log 10 to compute digits. Width equals floor of log 10 of max plus 1. Print header optional. Use a loop to print column indices with the same width. Print rows inside a nested loop. Use a format like %d, where star tells print to take the width from an argument. Example: 5 by 5 multiplication table. Int n equals 5. Int max equals n times n. Int w equals log 10 of max plus 1. Header print %s width blank. For j from 1 to n print space %d width j newline. For I from 1 to n print %d width I. For j from 1 to n print space %d width I times j newline. Output shows a table with column headings 1, 2, 3, 4, 5, and rows starting with 1 followed by 1, 2, 3, 4, 5, row 2 with 2, 4, 6, 8, 10, row 3 with 3, 6, 9, 12, 15, row 4 with 4, 8, 12, 16, 20, and row 5 with 5, 10, 15, 20, 25. Formatting floating point matrices. Use %*f, where the first star is the field width and the second star is the precision, the number of digits after the decimal point. Double a 2 by 3 equals 1.2, 3.456, 78.9, 0.0015 minus 2.34. Int w equals 8, p equals 2. For I from 0 to 1, for j from 0 to 2, print space %star dot star f width w precision p a I j, new line after each inner loop. Result aligns every number in an 8-character field with 2 decimal places. Analogy: think of arranging pictures on a wall. The width of each frame must be the same, otherwise the wall looks uneven. Using %d and %star dot star f is like telling a helper to adjust each frame to the same size before hanging it. These techniques let you satisfy the exact output format demanded by judges, especially when the problem statement shows a sample table. Question 1 - Circle properties. Read the radius r of a circle, a floating point number. Print the area A equals pi times r squared, and the circumference C equals 2 times pi times r. Use pi equals 3.14159266535. Output must show exactly 3 digits after the decimal point, and the 2 values must be separated by a single space. Input 1 line containing r's. Output 1 line A C, both with 3 fractional digits. Sample input 2.5. Sample output 19.635, 15.708. Const double pi equals 3.14159266535. Double r. Scanf %lf, ampersand r. Double A equals pi times r times r. Double C equals 2.0 times pi times r. Print %.3f space %.3f backslash n, a, c. Key points: use %lf for double in scanf, %.3f for 3-digit precision, and a space between the 2 format specifiers. Question 2 - Matrix summation. The first line contains 2 integers n and m, one less than or equal to n, m less than or equal to 100. The next n lines each contain m integers, forming an n by m matrix m. Compute the sum of each row and print the sums in a single line separated by a single space. Each sum may be up to 1 billion, so use long. Input example 3 4, then 1 2 3 4, then 5 6 7 8, then 9 0 1 2. Output 10 26 12. Int n, m, scanf %d ampersand n, ampersand m. For int I equals 0, I less than n increment I long row sum equals 0. For int j equals 0, j less than m increment j long val. Scanf %lld, ampersand val, row sum plus equals val. If I then print space, print %lld, row sum, print \n. Use %lld for long both in scanf and printf. The space before each sum is handled by a conditional if I print space, so there is no trailing space. A final \n ends the output line.